All right, let's jump right into this explainer. Today we're tackling a totally crucial developer skill, one that literally transforms writing code from a terrifying, stressful tightrope walk into, well, a confident stroll in the park. If you're a coding bootcamp student, you've probably been there, right? You change one tiny, seemingly harmless line of code right before a deadline, and boom! Your entire portfolio project just shatters. Yeah, we've all been there. That's exactly why we're talking about unit testing today. Because, the real goal of writing software isn't just getting it to work that one single time. The actual goal is making sure it stays working as your codebase inevitably grows, evolves, and changes over time.
So ask yourself, would you ever walk a tightrope without a safety net below you? Probably not. I want you to imagine writing thousands of lines of code with absolutely zero tests. Sure, it feels incredibly fast and thrilling at first, right up until you make a tiny tweak and the whole application comes crashing down around you. A lot of beginners kind of think testing is, optional, like a chore you can just skip when deadlines get tight. But let me tell you, in professional software development, without tests, bugs just hide in the shadows. Fixing things becomes super risky, and your development speed will literally grind to a halt. You absolutely need that safety net.
So here's our roadmap for today. We'll start with the coder safety net, then look at the anatomy of a unit test. After that, we'll see how frameworks make it easy, dive into testing the edge cases, compare unit versus integration testing, and finally, look at the long-term payoff.
All right, part one, the coder's safety net and how it actually protects your codebase.
So what exactly is a unit test? Basically, by verifying every single small piece of code completely on its own, you ensure that a random modification in one function won't accidentally break something else entirely unnoticed. A unit is literally just the smallest testable part of your application. Think of a single function, a specific method, or a class. Our main purpose here is to isolate that specific tiny block of code and prove beyond a doubt that it works exactly as intended, totally independent from the rest of your giant, complex system.
Let's make this concrete. Suppose you're building an online shopping app, and you write a neat little function that calculates discounts. Obviously, if a customer buys an item worth 1,000 rupees and they have a 10% discount, the result should definitely be 900 rupees. Now, imagine you, or maybe another dev, accidentally messes with that discount logic months down the line. Maybe they just tweak a percentage in a totally different file. If you have a simple unit test in place, it acts as a total safeguard. It actually stops those incorrect, buggy discounts from ever reaching your real-world customers, because that test is going to immediately fail and point right to the exact issue.
Moving right along to section 2, the anatomy of a unit test, specifically focusing on the famous AAA pattern.
Okay, so the absolute gold standard structure for writing these things is the AAA pattern: arrange, act, and assert. It goes like this. First, you arrange. That means you prepare your data, like setting up the exact numbers you want to calculate. Second, you act. You literally just execute the function you're trying to test. And third, you assert. You verify that the result is what you expected it to be. Keeping this simple 1-2-3 rhythm means your tests stay organized, super readable, and honestly, way easier to fix when they inevitably fail. And remember, your tests should actually be way simpler than the production code they're testing. Now, I really want to highlight that third step, assert. It is incredibly critical. Without assertions, your tests literally cannot verify correctness, which pretty much renders your entire safety net completely useless. An assertion is essentially you telling the computer, hey, I expect the result of this specific function to be exactly this value. And if it's not, sound the alarm. It's that simple.
Okay, section 3, frameworks make it easy. Because let's face it, we all love automating the process.
Look, writing tests completely manually and checking every single output yourself, that would be painfully tedious. Thankfully, we have some seriously amazing automated testing frameworks across pretty much every language that create, run, and track all these failures for you. If you're currently learning Python in your bootcamp, you're definitely going to encounter PyTest or unit test. Over in Javaland, JUnit is the absolute industry standard. For JavaScript developers, Jest and Mocha are everywhere. These frameworks give you the environment to run hundreds or even thousands of tests over and over again, instantly generating a report of what passed and what failed.
To give you an example, frameworks like PyTest are just massively popular in the industry because they automatically discover and execute your tests for you. It keeps your workflow incredibly fast and super clean. You really don't have to write tons of complex boilerplate code just to check if 2 + 2 = 4. You literally just write a simple test function, type the PyTest command into your terminal, and boom, it automatically finds all your test files and executes the whole shebang in a matter of seconds.
Let's dive into Section 4, testing the edge cases, or as I like to call it, slaying the monsters. So, a super common mistake beginners make is only testing the normal, happy path inputs. The stuff you actually expect users to type. But you absolutely must test the unusual suspects. We're talking empty strings, zero values, negative numbers, and just massively large inputs. You have to ensure that things like division by zero are handled correctly. Or, going back to our shopping example, making sure your cart doesn't violently crash if some user tries to order -5 pairs of shoes. Checking for these totally unexpected inputs is honestly the secret sauce to true code robustness. So to get that rock-solid robustness, you need a healthy mix of both positive and negative testing. Positive testing is just proving your code does what it should do under normal, everyday conditions. But negative testing? That proves your code doesn't completely explode when it's fed invalid or just plain weird data. Your application absolutely has to be robust enough to handle both of these scenarios smoothly without flinching.
Moving right to Section 5, unit versus integration testing, and defining the boundaries between them.
It's super common for beginners to kind of mix up these testing concepts, but the boundary is actually pretty clear. Unit testing is checking just that discount calculation logic we talked about, in total 100% isolation. Integration testing, on the flip side, is checking if that discount function actually plays nicely with the overall shopping cart and your payment processing systems. Think of it like a giant puzzle. Unit tests focus on the individual, small puzzle pieces. Integration tests focus on how those pieces actually fit together. They're both absolutely critical, but unit tests, those are always going to be your first line of defense.
And finally, Section 6, the long-term payoff, or how to start coding like a pro.
Okay, so when you finally have this beautiful safety net in place, something magical happens. Refactoring, which is just improving your code's internal structure without changing its external behavior, becomes so much safer. Let's say you really want to optimize a clunky old function so it runs way faster. If you don't have tests, you're probably going to introduce hidden bugs. But with automated tests, they instantly verify that your existing functionality hasn't broken during the cleanup. Plus, your tests basically act as living, breathing documentation. They show exactly how functions are expected to behave for the next developer who has to read your code.
And this is exactly why professional teams at places like Google, Microsoft, and Amazon rely so heavily on automated tests. At that scale, even a tiny, seemingly insignificant bug can affect literally millions of users. It just proves that testing is absolutely essential. In modern dev teams, using continuous integration, the very second you push your code, all these tests run automatically in the background. If even a single test fails, the code doesn't ship. No exceptions. It really is that simple. Now, you might hear teams throwing around the term test coverage. This just measures how much of your actual code is being executed by your tests. And sure, tracking test coverage is totally useful, but please remember this. Hitting 100% coverage absolutely does not guarantee bug-free software. No way. The quality of your tests, like how well you check those weird edge cases and handle negative testing, matters so much more than just the sheer quantity of tests you wrote. So don't just chase a vanity number, chase actual reliability. So as your bootcamp projects grow larger and a whole lot more complex, I really want you to embrace unit testing. Don't see it as this annoying chore, but as the ultimate safety net that actually empowers you to build highly reliable software. By creating small, fast, independent tests, you can confidently modify your software over time without that horrible dread of a late-night debugging session. I want to leave you with this final thought. If the code you spent hours and hours perfecting today just randomly broke tomorrow, how long would it take you to even notice if you didn't have a test? Keep writing those tests, guys, and I'll see you in the next explainer.
If you enjoyed this video and learned something new, like this video, comment your favorite programming language, subscribe to Future Break Coder, because many exciting coding and futuristic tech videos are coming soon.